Hey guys, welcome. This is our 3.7 video, absolute value equations and inequalities. So today we're going to solve equations and inequalities using absolute value. Okay, so let's go ahead and take a look at our first set of notes. So make sure you get your heading. Alright, first things up right here. Solving absolute value equations. So to solve an equation in the form of A with absolute value brackets equals B, where A represents a variable and B is any number bigger than 0. We solve A equals B, and we also solve A equals negative B. Remember, absolute value bars essentially mean the distance away from 0. So go ahead and write this down real quick. But if I took the absolute value of negative 5, and I went ahead and I plotted on this number line, we have 0 here, negative 5, be 1, 2, 3, 1, 2, 3, 4, and 5. So absolute value is the distance away from 0. Well, distance can never be negative. So how far is it away? 1, 2, 3, 4, 5 units. Okay? So the absolute value of negative 5 is a positive 5. So when we're solving an absolute value equation, we can actually plug in the negative or the positive as a solution. That's why you see B would work just like 5 would work in the position of A. Absolute value of 5 is 5. Or negative 5 would work, because absolute value of negative 5 is also 5, because they're both 5 units away from 0. Okay? Alright, let's look at one more piece. Okay, when we get to inequalities with absolute values, it gets a little bit tricky when you see a, let's see, so you're going to write all this down. But this is the key piece right here. When you see a less than sign, I like to write it out as less, not than, but less, than. Okay? This is a less than symbol, but it makes an and inequality. Okay? They're overlapping. So when we see that less than, we're going to do an overlapping inequality. Versus when you see a greater symbol, like this is a greater symbol, then we're going to actually see and I like to spell it out as great or, because we're going to see an or problem. So the absolute value gives us an and, a compound inequality and it gives us an or problem. Less than, greater. Alright, let's get to some examples. Okay, so here's our first example. We want to get the absolute value part by itself first. This is example 1. So to get rid of that 5, I'm going to add 5 over. And we're going to get the absolute value of n equals 3. Now, this number always has to be positive because absolute value is going to come out positive. So if it was negative, we'd have no solution. Okay? So once we have the absolute value, this is when I break it down into case 1 and I say case 2. Okay, because we have 2 different cases. This is going to go very fast because n could equal positive solution here, 3, or it could equal the negative solution. And since there's nothing else to solve, we're done. Let's get another one. Okay, so in problem number 2, we see that it already has the absolute value piece by itself. See, there's nothing on the outside. All the absolute value stuff's on the inside. That means we can break it down into our 2 cases, case 1 and case 2. Case 1, we rewrite the equation exactly how I see it. There's a weird creative cloud over my face. Get away from me. Get away. So we do 3x minus 1 equals 8. Then we write the same equation, except for instead of equaling 8, inside could equal a negative 8, because if you took the negative 8, it would come out as a positive. So we solve both of these, add 1 to both sides. We get 3x equals 9. Divide by 3, and x will equal 3. Over here, we add 1, but this time we're adding 1 to a negative 8, so I get a negative 7. And then I divide by 3, and I get x equals a negative 7 over 3. Okay, that doesn't go in perfectly, but I can get fractions as answers. That's okay. No big deal. Okay, so that's what it would look like if we had stuff inside of the absolute value piece. Now let's look at absolute value with inequalities. We'll do two more. Okay, so here's example number 3. And see how the sign is a greater than sign? So I automatically just write great or, and I'm going to make two equations. I'm going to get 2x plus 4 is greater or equal to 5. Okay, and then I like to do the other equation over here. This time we're going to switch two things. We switch the sign and we also switch it to negative. So we switch both pieces there. Okay, so notice that these are different than these. We switched it. And then in the very middle, we put the word or. Now we just solve. Subtract 4 from both sides, and we get 1. Divide by 2. X is greater than or equal to 1/2. Over here, subtract 4. That's a negative 9. And then divide by 2, and we get negative 9 over 2. And it's an OR problem. Notice 1/2 is bigger than 9 over 2, so we're going to graph it. And we get 1/2 over here. 0 is somewhere around here. And we get negative 9/2 over here. Both are greater than or equal to, or sorry, have the equal bar, so we're going to include them. It's OR, so I know I'm going to graph all towards. Okay? OR. So this is a great OR. Again, this symbol, great OR, means we're going to graph outward and create an OR equation. And we write it the exact same way, and then we flip the inequality and we give it a negative. Let's look at one more. Okay, this last one I just wrote myself, but this is a absolute value inequality. And the first thing we notice, this is a less than sign, so I like to write less than. So we're going to make this into an and problem. And the way you make it to an and problem is you do the exact same thing, is we write this piece just like that. We drop the absolute value, but then we're going to throw in another one over here and put the opposite on the other side. So it looks like an and problem. We took positive 14 on the right and we put negative 14 on the left. Then all we have to do is solve. So just when I divide by 2, I make sure I do it to both sides like we did the other day. We get negative 7 less than x, which is less than 7. And when we graph, we get negative 7 over here, positive 7 over here, open circle, and then you graph in the middle. And you're all set. All right, thanks guys.